Hi, this is Mrs. Ertl, and I am going to be walking you through some of the Simple Machines notes. This is the notes that are in Schoology at the bottom of the folder that says Simple Machines. These learning targets I'm not really going to talk about. These are the same ones that are on the bottom of your checklist on the front page of that packet. And yes, you are expected to know and be able to do all of these things before the test at the end of the trimester. Some of these things I'm not going to talk about too much. Machines are just anything that has moving parts that helps us do something. A bicycle is actually considered a complex machine or a compound machine because it has multiple simple machines together in one thing to do a job. The 6 simple machines that we're going to be using are these ones here: a wheel and axle, rope and pulleys, wedge, ramp, screw, gears, and levers. Some would argue that some of these are not simple machines. Some are simpler than others in some opinions, but these ones are the ones that we will talk about. The big thing today that I want to talk about in this video is about mechanical advantage. And this is the reason that we use machines. We use machines to multiply our force, to make our force larger so that it is easier for us to lift or move something. What the mechanical advantage tells you is how many times the machine multiplies your force. So if you have a machine that has a mechanical advantage of 4, it in a sense makes you 4 times stronger. You can lift something 4 times as heavy that you compared to what you would normally be able to lift. Some really important definitions on this page. Input, sometimes called effort, is what you put into the machine or what the person applies. And that's a force. It can also be a distance, depending on what machine you're using, but input is always you or wherever the person would be. Output is what the machine does. It's the weight of the object you're moving. It is the resistance or the load are some other words that would be used to be the output. And we're going to be talking about lots of kinds of mechanical advantage. Today, this one is on what's called actual mechanical advantage, where you compare the force out, so the force applied by the machine, divided by the force in, which is the force applied by you. And that will get you actual mechanical advantage. Now, if you notice on the forces, that over here with the forces, these are in newtons, but mechanical advantage has no units. That's because if you think about this as newtons divided by newtons, when I divide those things, they disappear and I'm left with no units. So mechanical advantage is a proportion or a ratio, so it has no label at all. It just tells you how many times your force is increased. So an example of this, what is the mechanical advantage of a lever that allows Jorge to lift a 24 Newton box with a force of 4 newtons? Well, first I have to think which one is output and which one is input. And if you remember, the input is the person, so the 4 newtons is going to be the force in. Sometimes I put F in instead of Fi. And this is going to be the weight of the object is force out. So that if I'm using AMA equals force out over force in, I will have 24 newtons over 4 newtons, and that will be 6. And again, there's no label because when I do this, newtons cancels out. Sorry, I'm going to make my ink a little bit thicker so that newtons is on the top, newtons is on the bottom, it disappears from the equation. So that's how you would find mechanical advantage. What if I want to find one of the other things? If the mechanical advantage of a ramp is 3.5, what is the input force needed to move an 85 Newton box up the ramp? Well, it's asking for input force, so this must be output force. And it tells you right here that this is the mechanical advantage, or the AMA. So if AMA equals force, sorry about that. Let me erase that. Try again. AMA equals force out over force in. I apologize, I'm kind of making a mess here. So when I do this one, the AMA is 3.5. The force out is 85 newtons. And the force in, we don't know. Now remember, this is the one where many people make the mistake. And the first thing I have to do here on this one is multiply both sides by force in. So that this disappears. And I'm left with, if I rewrite this, force in, so I'm going from here to here, times 3.5 equals 85 newtons. So this would be 85 divided by 3.5. Which would give you a force in of 24.3 if I round. And this would be newtons. Because it is a force, it has to have a label of newtons. Now, if you hate doing that and you like my rearranging, I can start over. And the triangle for this one would have force out on the top, AMA in this corner, force in this corner. So if I'm looking for force in, it's equal to force out over AMA, which means I would have 85 newtons over 3.5, which will again give me the exact same answer of 24.3 newtons. So either way you do it, you're going to get the same answer. If you are looking for one more example, this one is, again, finding something other than mechanical advantage. It says here that the machine has a mechanical advantage of 7, and that the weight of the box, or what is the weight of the box if it takes an input force of 55 newtons? So this is force in. Again, just using the exact same formula. Force out over force in. AMA is 7. Force out, we don't know, over force in of 55 newtons. So I would take 55 times 7 when you rearrange and get a force out of 385 newtons. Again, if you like the triangle, and I start over, I would have, with that triangle being AMA, here's your triangle, AMA, force out, force in, I'm sorry, I'm hitting the wrong buttons here. That's supposed to be an I. I would have force out is equal to AMA, force out equals AMA times force in. So I would have 7 times 55 newtons, which gives you, again, the same answer of 385. And this is newtons because it is a force, so it has to have newtons behind it. So that is it for this